Take this expression, A or B, and not A or C. Your job is to make this whole thing true. The only thing you're allowed to do is set the values of A, B, and C. And these are Booleans, so they can only be set to true or false. Can you find the values of A, B, and C that make this whole thing true? Pause this video and take a moment to try to do it in your head. 3, 2, 1. Okay, now let's look at a solution. If you set A to false, B to true, and C to true, then you get false or true and true or true, which reduces to true, and true, which reduces further to true. Voila, the formula is satisfiable. Now, imagine doing this same process, but with thousands or millions of variables and clauses. That's what industrial SAT problems look like. That is, Boolean satisfiability problems. And unlike my example, SAT problems are usually not contrived. They come from real-world systems, circuit designs, software verification tasks, cryptographic analysis, etc. And the fact that they come from the real world gives us an opportunity to solve them more quickly and efficiently than anyone thought possible. At least that's according to the authors of today's paper. They argue that real-world SAT problems aren't just random collections of variables and clauses. They have structure, and that structure means there's an opportunity to break up the problem into a bunch of smaller ones, cutting the total completion time down to a fraction of where it started. On today's episode of Journal Club, we're going to walk through their strategy in detail, learn how it works, and find out which kinds of problems it's best suited to speed up. If you're already subscribed to our email newsletter, then you'll be getting this episode in text, audio, and video form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.